Hello everyone. This session let's discuss about the new concept of the domain of expression of the equation. So, what's the domain of equation? Normally we just ask for the range of the x. Ask the range of x. Uh, Give an example here. You can see a is x equals to 1. In fact, the equation will be y equals to x minus 1. So what we are here, we are not asked for what y's range, we ask was x range, because from x range we can find what's y's range. Same as the number b example, number c example, right? We can write it as y equals to tangent data, right? Okay, so simply speaking, we look for the range of the x, not y. So let's see here. Okay, let's give some example to show that. So for the example A, x minus 1, what's the range of this expression? Can x be 1? Yes. Can x be negative 1? Can x be square root of negative 2? No, right? Square root of negative 2 is not a real number anymore, right? So we now talk about just real number. So since x can be anything in the real number, so we write it as x belongs to R, real number. So this is the domain. How about the second one, tangent data? In fact, you can draw the graph of tangent data, so you might see. But here I use another way. So tangent data equals to what? Equals to sine data divided by what? Cosine data, right? So sine data can be anything. I don't think there's any problem. But the only problem is cosine is as a denominator, it cannot be 0, right? So the only thing cannot be 0 is cosine data cannot be 0. Cosine data cannot be 0. What's that mean? So the data should be what? Let's remember what's mean. Sorry, it's not really straight. So see, this is x, this is y. Cosine is what? X over r, y equals to r, y equals to r, right? Remember, if this is the angle. So here cannot be 0. R definitely cannot be 0, right? R definitely cannot be 0, right? R cannot be 0. Okay. So R cannot be 0, which means y have to be 0. So the expression is 0, right? Because the denominator r cannot be 0. So y equals to, at what condition the angle y will be 0? It's only the condition is, right? Only the condition is y is this 9, the second 9 of the angle is 9 on the x-axis. Am I right? 9 on x-axis, so y equals to 0, right? So y equals to 0. So delta cannot be what? Cannot be pi, right? I think k pi will be okay. And the k will be k will be any integer, but it will be including the 0. Wait, k will any integer, right? K will belongs to integer, right? Right? K is 1. K is 1 is here, and k is 1. K can be 0, right? So integer plus 0, right? So k is 2. Oh yeah, k pi. So what's the domain of here? Domain of the tangent data is what? The data should be okay, should be uh, R, but except right, k pi. Am I right? Right, you can write it like this way, right? Okay, so let's see the third one. This expression, what's the domain? First we observe for the denominator is what? As a square root, right? The square root, the number inside them cannot be negative, right? So here, denominator part x minus 2 have to be bigger or equal to 0, right? Below is what cannot be 0, right? 1 minus x cannot be 0, right? So let's see, it's 2. So first one, so x squared have to be greater than equal than 2. So the answer, it will be x greater than equal to 2 or x less or equal than negative 2. And based on the second one, 1 minus x, so x cannot be 1, right? Okay, so in order to clearly express it, let's just draw this is a real number domain, okay? This is a real number domain. It can be both sides because it's real number. This is a real number, go to the positive side. This real number, go to the negative side. Okay, so here, x cannot be 1. Cannot be 1. Here's 1. If this cannot be, we just draw a empty circle. Cannot be. Sorry, why it's 1, right? And or x greater or equal than 2. Here is 2. So it's here, this side, right? Or equal or less than negative 2, right? So here, negative 2. So definitely if we just look out less than negative 2, greater than 2, so not including 1, right? So we don't need to count in 1. So the domain will be what? Domain will be look here, Look here. This group sign, right? I will write in this one infinity, and the negative, so go to negative infinity, and then negative 2, and then bracket, right? Because included, and then if you remember this sign is in a set, right? Union of what? Same bracket 2, and then we go to the positive infinity. This is the domain of number 3, right? Okay, so now you get it. So we go to another conception. One is identity equation. Another is a conditional equation. In fact, these are opposite conception. This is based on we just talked about the domain, right? If the domain is R, then it's identity. If the domain is not R, then it's conditional. Just that easy. Okay. So I have 3 examples. Yeah, 3 examples here. I ask you to find whom 3 equation, right? A function. Which one of them are identity? Which of them are conditional equation? Let's open the first one. X squared minus 1 is equal to x plus 1, x minus 1. In fact, this is the same, right? X squared minus 1 is exactly equals to x plus 1, x minus 1. I think any number put inside, any real number put inside, this will be universal, right? So this will be the conditional equation. No, identity, right? So identity equation. So I just writing them. Okay, identity equation. How about the second one? Cosine data equals to sine data. Is that universal? R? Definitely is no, right? Because cosine 90 is not equal to sine 90. Am I right? Cosine 90 is 0. I mean 90 is a degree. Okay. Or you change to the radius, it will be cosine pi over 2, and it's not equal to sine pi over 2. Only what condition they are equal? When theta equals to pi over what? 4. They're same, right? They're same, right? They're same. Only, and here we can write in as mm, pi 4, yeah, pi over 4 or 5 pi over 4. They're also same. Okay. Or and then those including like 2 pi plus 2 pi or 4 pi or some 2 pi's because it's the same as we talk about. They have the same end 9 under 9 of the circle, so they are same. Okay. So this definitely is conditional. Number 2, right? How about number 3? This is a little confusing. In fact, this looks like what? Looks like identical, because if you're uh, times 1 over x, well, sorry, 1 plus x on both sides, so 1 plus x and then y minus x. In fact, they are same, right? Similar as what we see. This one is no difference. But the condition here is they have fraction here. So on the right side of this equation, x cannot be -1. Am I right? But on the left side, x belongs to r. Am I right? So definitely not, they are not equal, right? So since they are not equal, they are not identical, they are conditional. Okay, so today we just spend some time to discuss about the domain of the equation, as well as the concept identical and conditional equation. Okay, so this will be extension of the equation. We added those information of the what we learn now is the trigonometry, right? So thank you very much to join this session. Thank you. Have a nice day. Bye bye.